The Metasperga was alive 514 million years ago. The Metasperga had no vertebrae, which led it to move in the motion similar to a snake. In the atmosphere, there was a buildup of oxygen, which led to euphoric forms in algae. Paleontologists found fossils that identified fossilized fish specimens from the Cambrian period. These fossils showed arches in the front of its body, which would eventually evolve into jaw hinges. The Cladoche was alive 370 million years ago. Its mouth was at the front of its head, unlike sharks today. They also had tooth-like scales that provided protection. Unlike modern sharks, they didn't have claspers that males used to mate with females. The environment was dominated by brachiopods, which built large reefs in shallow waters. It had a streamlined body with 5 to 7 gill slits, and it had a mouth opening at the very front of its skull. It had very weak jaw joint compared to modern-day sharks, but had very strong jaw-closing muscles. The Phalcetus was alive 330 million years ago. It had very large eyes for its size, which was an adaptation for deep water hunting. There was less light. Also, after the loss of the dorsal fin, which would usually be above the pectorals, the tail fin strongly developed. This shows that the Phalcetus was a fast swimmer that was able to chase after its prey. It was 25 to 30 centimeters long, and they had prominent fin spines and curved entirely over the head of the shark. Ammonoids appeared, which led to large amounts of limestone deposits from their shells. The Stephacanthus was alive 320 million years ago. The Stephacanthus immediately stands out from other sharks. Unlike the triangular dorsal fin, the dorsal fin was shaped like an oval covered in small spikes. These spikes were larger versions of scales that cover the entire bodies of sharks. They are used by reducing drag and allowing sharks to swim faster. The Stephacanthus would have no problem recognizing others of its own species. This period of time underwent a large amount of radiation, giving a rise to the golden age of sharks. This lasted about 250 million years ago, until a large massive extinction killed about 99% of all the ocean's population. According to fossil evidence, it is related to the Stephacanthus because it has similar gill placement. The Megalodon has one large dorsal fin and a stronger jaw. Their teeth have the ability to regrow so multiple sets can grow up to one time. The marlin shark can live in as many different types of environments, but all sharks do live in saltwater. The temperature of the water depends on how close they live to the equator. I predict that the shape of its head will change and the size of its eyes will enlarge, so it can see better in deeper waters. The environment of the shark changed over time because during the Devonian period, the world's land masses were locked up in a supercontinent called Pangaea. This meant that the world had lots of open ocean. There are few places to hide and lots of predators. Natural selection is when one biological feature of an animal is successful in helping the animal survive and one fails. The one that is successful is passed down through generations to help the species survive. The early ancestors of sharks selected mates that had stronger abilities to help them survive. The adaptations of the dorsal fins and scales have become more slim and in triangular shape, which have led the shark to swim faster and be more efficient for catching prey. The jaws of sharks evolved to become stronger and faster. The prey of sharks has also evolved to swim faster, which could lead to the extinction of sharks if they haven't evolved into the modern shark today.